We're going to talk about section 6.5. We'll call it 6.5a, absolute value equations, and or equalities, however you want to think about it. And then our next lesson will be absolute value inequalities. So we've got section 6.5a, solving absolute value equations. So here's a question. If we had the absolute value of x equals 10, what could x be? What could x be so that if we took the absolute value of it, it would be equal to 10? Okay. Hopefully most of you have thought of the first possibility, which is x such that x could equal 10. But what else could x be so that when we take the absolute value of it, we also get 10? Think hard. Not positive 10, but negative 10. So when we take the absolute value of something and it's equal to a positive number, then the value of what is inside here can either be the positive version of this or it could be the negative version of this. So we need to keep that in mind as we're solving our absolute value equations. Let me give you our first example. The absolute value of 2x plus 7 equals 9. Okay, what does that mean? That means either 2x plus 7 equals positive 9, so either what is inside here is equal to positive 9, or what is inside here is equal to negative 9. Because if this is equal to positive 9, when we take the absolute value of it, it equals 9. Or this, if this is equal to negative 9, when we take the absolute value of it, it would be positive 9. Okay? So as we do this, we're going to go ahead and write some steps for solving absolute value equations, and you can write these on your Cornell note sheet, solving absolute value equations. So the first step would be, number 1, if the absolute value is not isolated, you need to isolate the absolute value. In this case, the absolute value is already isolated. There's nothing on the outside of the absolute value on this left side. So we don't need to do step number 1. Once you isolate it, then you need to set up two equations. One is going to be equal to the positive of the value on the right. One is going to be equal to the negative of the value on the right. And then number 3, solve both equations. So notice when we split it into two equations, the absolute value bars have dropped out. Okay, you don't want to confuse yourself further. So once it's like these two absolute values bars split and make the two equations, and here are our two equations. So then we want to solve both of them. Subtract 7, subtract 7. We end up doing the same thing in this one. 2x equals negative 16. Negative plus a negative is another negative. 2x equals 2. Divide by 2. This one's also going to be the same step, so we get x equals 1 and x equals negative 8. Now let's check both of these mentally, or I'll write them down. 2 times 1 is 2, plus 7 equals 9. So 2 plus 7 is 9, the absolute value of 9 equals 9. That one works. Negative 8. 2 times negative 8 would be negative 16 plus 7. Negative 16 plus 7 will give us negative 9, and the absolute value of negative 9 does equal 9. So they both do work. That's why we get two equations, because this one gives us a positive 9, we take the absolute value of it. This one gives us a negative 9, and we take the absolute value of it. So our set notation should look like this. X such that x equals negative 8 and positive 1. And really the order that you write these two numbers won't matter. You can write them in either order. Some people prefer in order of their size. Some teachers don't care either way. Okay, so there's example 1. Let's move on down a little bit. I'll put example 2 on the right here. Let's put this in a box if you wrote it on this page. it's on your Cornell note sheet, then that's even better. So example number 2. 3 plus the absolute value of negative 2x plus 9 equals 10. So notice there's a 3 plus on the outside of this absolute value. According to our steps, we need to isolate the absolute value first. So we need to get rid of this 3. How can we get rid of that 3? That's right, we're going to subtract it and move it to the other side. So that drops out. We get the absolute value of negative 2x plus 9 equals 7. Now we have the absolute value isolated, and we're going to set up our two equations. Negative 2x plus 9 equals 7. Negative 2x plus 9 equals negative 7. And then solve both equations. Subtract 9. Divide by negative 2. Okay. I'm going fast because we should know how to solve equations. So undo addition and subtraction first, then divide by 2, negative 2 in this case. On the right side, same steps actually. Subtract 9, we get negative 2x equals negative 16. Divide by negative 2, and we get x equals positive 8. And we put these into set notation, x such that x equals 1 and 8. I put them in order from smallest to largest. But you, again, do not have to do that. Let's try one more. That's a little more challenging, and then I'll give you a chance to try a couple on your own. So number 3, 1/4 of the absolute value of x minus 3 plus 6 equals 8. Now we have to isolate the absolute value, and in this case we've got more than one thing we have to do to isolate the absolute value. So we've got this 1/4 out here, and we've also got this 6. Which one of these do we get rid of first? We always undo addition and subtraction first, so we're going to move this 6 over. We get the 1/4 of the absolute value x minus 3, drops out, equals 2. Now, to get rid of the 1/4, the next thing we can do is multiply both sides by 4. In this case, 4 over 1 and 4 on this side, so 2 times 4 gives us 8. Now the 4 over 1 and the 1/4, they cancel each other out, and that's the whole point of it, is to get rid of that 1/4. So all we're left with is the absolute value of x minus 3. One thing you need to understand is that you can never get inside these absolute value bars. So if there's a number outside here, you can never distribute inside the absolute value bars. You have to get rid of that number. So once we get here and we've isolated the absolute value, now we're going to split it into two equations. X minus 3 equals positive 8, and x minus 3 equals negative 8. And then we go ahead and solve both equations. For both of these, all we need to do is add 3. So we get x equals 8 plus 3, which is 11. And add 3 here. X equals negative 5. And put them in set notation. X such that x equals negative 5 and positive 11. Okay. Why don't you try this one on your own and see how you do? Number 4. Now if you do this correctly, you will get 2 mixed numbers for your answers, but it's only that final step that is difficult. It's not even that difficult. 3 times the absolute value of 2x minus 4 plus 6 equals 9. Go ahead and pause this and try this one on your own, please, and then come back and see how you did. All right, let's see what we did. Now we've got multiplying by 3 in the front and adding 6 in the back. So we want to undo addition and subtraction first, just like we did on the previous problem. Subtract 6, and we get 3 times the absolute value of 2x minus 4, these drop out, equals 3. Now, again, we cannot distribute this 3 inside the absolute value, so we need to get rid of this 3 by dividing both sides by 3. Those drop out, and we get 2x, the absolute value of 2x minus 4 equals 1. Don't forget the absolute values. The absolute value bars will not drop out until you split it into two equations, which is what we're going to do next. 2x minus 4 equals positive 1. 2x minus 4 equals negative 1. and then go ahead and solve both equations. We're going to undo addition and subtraction first, so we add 4 to both sides, we get 2x equals 5. Add 4 to both sides here, we get 2x equals 4 minus 1, which is 3, and then divide by 2. Now these answers can be given as mixed numbers, or you can leave them as improper fractions. So x such that x equals 1.5 and 2.5, or you can just write x such that x equals 3/2 and 5/2. As long as these are reduced, and these are reduced, they can't get any smaller. You can either leave them as impropers or as mixed numbers. How'd you do on that one? Let's try this one. This one's a little different, number 5. X plus 5 equals the absolute value of 2x minus 4. What makes this one different? Yes, there's variables on both sides. So what do we do about that? We have to isolate the absolute value, which the absolute value is already isolated. Something that might make everybody a little more comfortable is if you look at all the previous problems, the absolute value is on the left side, on the left side, on the left side. So what we can do, if this makes you feel a little better, is move this from this side over to this side. Okay, so this is where the constant or the whole number was in the previous problems. What did we do then? The absolute value was isolated, so we split it. So we get 2x minus 4 equals the positive version of this, which this is the positive version of it, or 2x minus 4 equals the negative version of it. Now, you cannot just put a negative in front of it without the parentheses, because then you're only making the x negative, or the opposite. So you need to put a negative in front of the whole thing and put parentheses around it, so we're making the whole thing negative. That is the toughest part. Once you've done that, then it's just a matter of solving the two equations. Why don't you take a minute and try to solve those on your own, and then come back and see how you did. All right, so we've got variables on both sides. So we want to move this x over to this side. 2x minus x is x. And then move this 4 over by adding 4. So we get x equals 9. Over here, we've got to distribute this negative sign. So we get 2x minus 4 equals negative x minus 5. And we still want to move this x over, because this is the smaller one, so we add x to both sides this time. 2x plus x is 3x. And we add 4, and we get 3x equals negative 5 plus 4, which would be negative 1. And then divide both sides by 3, so we get x equals negative 1/3. Okay. So our set notation would be x such that x equals negative 1/3 and positive 9. Okay, let me just go back and go over that one more time. So if you have variables on both sides, we still do a positive version and a negative version. The positive version is exactly the same as the original. And the negative version, we just put a negative outside, put parentheses around it, so we distribute the negative throughout the whole thing. Okay, one more problem together. Number 6. Write this down. Now this one, 3 times the absolute value of 2x plus 5 minus 2 equals negative 14. Okay, why don't you try to solve this one and see how you did, and come back and check it. Okay. All right, so what do we do first? We've got a 3 outside, which shows this multiplication, and we've got subtraction. So we always undo addition and subtraction first, so we add 2 to both sides. 3 times the absolute value of 2x plus 5 equals negative 12. What's next? We want to get rid of this 3 next, so we divide both sides by 3. Drop out, we get the absolute value of 2x plus 5 equals negative 4. Now here is where it's different from all the others. So whether you finish this problem or not, Look at this step right here. How is this different from all of the other problems? We've got an absolute value on the left side and it's isolated. But what do we have on the right side? We've got a negative number. Is it possible to take the absolute value of something and get a negative 4? Can we take the absolute value of positive 4? That gives us positive 4. What about the absolute value of negative 4? That gives us positive 4. Okay? No matter what, when you take the absolute value of something, you're going to get a positive number. So if you are trying to solve an equation where it says the absolute value of something is equal to a negative number, this is not possible. So the answer to this absolute value equation is no solution, or the empty set. This will not work. All right, go back and check your problems. See if you have any questions. Bring those to me tomorrow in class.